Now we get to the last part of our impulse and momentum discussion, explosions. Explosion. Just like with collisions, momentum conservation is useful in analyzing explosions. That is to say, we use conservation of momentum to analyze explosions. When you see the problem talk about an object exploding or breaking apart into smaller pieces, you use, for the most part, momentum analysis. Conservation of momentum, initial momentum is equal to final momentum. You can use actually conservation of energy in analyzing explosions, but that's only if you can account for the energy, kinetic energy of each and every piece of the object before and after the collision, and you also have to take note of the energy that is converted into heat and sound during the explosion. Whereas in conservation momentum, you just look at the momentum of the pieces and the object before and after the collision. Initial momentum is equal to final momentum. So let's have one example for explosion, and that will be it for our impulse and momentum discussion. Consider the following problem. A soldier drops a 0.6 kilogram grenade into a well. The grenade free falls and reaches a speed of 20 meters per second before exploding. It divides into three equal parts. One part flies vertically downwards with a speed of 100 meters per second. And a second part flies to the right at 60 meters per second. What is the speed of the remaining part? So basically, this is an idealized grenade. We know that when something explodes, it basically breaks into thousands, hundreds of thousands of pieces, depending on the explosion. But for this grenade, it only divides into three equal parts. Initially, there's only one object, the grenade, zero point 0.6 kilograms in mass, so let that be mass m. M is equal to 0.6 kilograms. After exploding or after the explosion, the object divides into three equal parts. You have M1, M2, M3, equal parts, so equal masses. M1, M2, M3 are equal to 0.6 divided by 3 equal parts. So M1 is equal to M2 is equal to M3 is equal to 0.2 kilograms. Before the explosion, the object is moving at V naught is equal to 20 meters per second. One part of the grenade, after it explodes, one part goes vertically downwards with a speed of V1 is equal to 100 meters per second. And the second part flies to the right, horizontally to the right, with a speed of V2 is equal to 60 meters per second. What is the speed of the third part of the remaining part? So what is V3? Using conservation of momentum, initial momentum is equal to final momentum. Initial momentum, there's only one object, so P initial, P naught. And then final momentum, you have three objects, so you have P1 plus P2 plus P3. So P naught is equal to P1 plus P2 plus P3. Expanding the equation or momentum to mass times velocity, you have mv initial is equal to m1 v1 plus m2 v2 plus m3 v3. Using component method, x component. V initial is vertically downwards. The object was free falling, so heading downwards. No horizontal component. So MV initial is 0. The first part, V1 or MV1, is heading vertically downwards, so no X component also. Whereas the second part is flying to the right, positive X direction, so plus M2 V2. And then for the third part, we are looking for V3, so variable. We use only variable for the velocity. M3 V3X. V3X, X component of V3. This equation of conservation of momentum X component tells us therefore M3 V3X is equal to negative M2 V2. V3x, therefore, since M1 is equal to M2 is equal to M3, we can cancel out mass. V3x, therefore, is just equal to negative V2. Knowing V2, we get V3x is equal to negative 60 meters per second. Going now to the y component, you get negative mv initial is equal to negative m1 v1 plus 0 plus m3 v3y. Isolating v3y, we get m1 v1 minus mv initial divided by m3. And we are able to get the y component of v3, 40 meters per second. And knowing the x component and y component of v3, we are able to get the magnitude of v3, the speed of the third particle. We use Pythagorean theorem. V3 is equal to square root of v3x squared plus v3y squared, and we get 72.11102.551 meters per second, the speed of the remaining part. And that's it for our discussion on impulse and momentum. So thank you for watching.